for this first simulation, I'm gonna take you through the overview of the system. So we have material streams, then we have pressure changes, which is the orifice plate, the compressor, the pipe segment, and the pump. So for this one, I'm gonna try to simulate a simple fluid flow question. So I'm gonna take my material stream, drop it here. So the material stream is blue, which means the interaction parameters for my thermodynamic model actually relate to the material that I have chosen. So I'm going to choose my pressure changes, then I'm going to take my pump, add it here, and then I take a stream, then the material stream for the product, I'm going to drop it there, and an energy stream for my pump. So for my pump one, I have to click my pump one, and then in the box circles and closes the pump, I'm going to choose my inlet stream to be MSTR01, my outlet stream MSTR02, my energy stream as STR01. So there's so many ways in which I can modify the calculation for my pump. For example, we can have a pressure increase. So that actually means that given my need to have a higher pressure of MSTR here, I can actually determine the pump efficiency by the increase in pressure. So I'm going to click on my pump, and then I'm going to take my pressure increase as my calculation type. So that implies that my pressure, which I specify in MSTR01, which is the material stream 1, will actually be added to the pressure increase value, which I'm going to input here, and will give me the pressure of my material stream 2. And based on this, if my efficiency is 75%, I can get the value of energy that I'll have to supply to the pump to get that value. So I'm going to click on my material stream 1, then I'm going to specify the stream condition. So for example, stream condition, compound amounts, water is actually 1. So accept changes, that actually specifies the composition of the infeed of the feed you're input into your system. So I'm going to stream condition, flash specifications, temperature, pressure enthalpy, pressure entropy. So I'm going to just choose my temperature and pressure, because we said for a thermodynamic system we need only we can explain the state of the property or the state of the system using two thermodynamic properties. So I'm going to take temperature and pressure. I can use pressure solid fraction, temperature vapor fraction, pressure vapor fraction to describe the state of the system. So my temperature, I'm going to take to 98.15 Kelvin. Pressure is atmospheric pressure, 1 atmosphere. The mass flow rate, I'm not going to tamper with that. But my pump specification, I'm going to make my pressure increase to about 300. It's just a value I'm going to take arbitrarily. 75% efficiency, so I'm going to click enter on that, and then it solves itself. So actually you see the system transforms from red, partially red, to blue, which means that it has actually solved the flow sheet successfully. So if I click my material stream 2, I'm going to have my pressure to be should be 101,625, because actually it was 103.25. So it actually did a pressure increase of about 300 pascals. So we have 101,625 my mass flow, and that does not change because the pressure changes. So if you are supposed to, so I want to give you an assignment. I actually want you to try and calculate from your energy balances the energy that will be supplied to the pump using the mechanical energy balance equation, and try to solve for a pump efficiency of 75. Try to find the energy input that will be required by the pump. So if I take my stream 2, so energy flow in should be about 0.000400184 kilowatts. So that will be all for today, and I can also tabulate the results. So but I'm not going to do that now. It's introduction. We'll do that later. Thank you.